So we are going to take up banking of roads topic under laws of motion chapter. Okay. So in the last video we have learned that when a vehicle takes a circular turn on a flat surface, it will have maximum velocity. This is a maximum velocity possible. Okay. If it takes a turn of radius r, this is what it can have the maximum velocity. If its velocity goes beyond this, the car will skid. Okay. Now this velocity may be a very small number. Okay. So that is the reason why people started thinking that can I increase this maximum velocity or like for example, if I get only 10 meter per second, which is maximum velocity possible, can I make it 12? Okay. Now you can't change coefficient of friction, right? You want radius to be that only, and g is anyway fixed. Okay. So one way to achieve to increase the maximum velocity without skidding is to bank the roads. Banking the road means that roads are inclined like this. Okay, they are not flat. Alright. So imagine a situation where a car is moving on a banked road. The road is coming out of the your board. Alright. So the car is coming like this. Alright. Now imagine a scenario where car is taking a turn like that on a banked road. Alright. This is what is happening here. Okay. So let us find out what is the maximum velocity that a car can have when it takes a turn in the banked road. Alright. This is the case with the flat road. Okay. Now we know that if a car takes a turn of radius r, it will have a centripetal acceleration, right? So I'll mark that here. Centripetal acceleration is always towards the center. Its value is v square by r. Okay. Now let us draw all the forces on this car. One very obvious force is gravitational force. So this is mg, right? Another force is normal reaction from the road itself. Now, normal reaction from the road will be along the common normal between the car and the road, and normal reaction always pushes. So it will be along this direction, okay, which is 90 degrees to this plane, and it will have friction. Now, can you guess which direction the friction be? If suppose it takes the maximum possible velocity turn in the radius r, which direction the car will, tend to skid? It will tend to skid outwards. It will tend to increase its radius, right? So friction will oppose that relative tending motion, okay? And friction will be always applied tangent to the surface, right? So that is the reason why friction will be applied in this direction. Okay, let us say that friction is Fr. Okay, now we have drawn all three possible forces on the car and we have shown the acceleration also. Okay, so let us resolve the forces and write down Newton's second law of equation. This is how we write in a scalar form, right? M into ax, and sum of all forces along y direction is m into ay, right? Now, first I need to choose my xy axis. So I take horizontal and vertical axes. Okay, this is the way it is given in your textbook. Okay, you can also choose xy axis, one along the incline and other perpendicular to incline. Okay, so let us follow the way it is given in your book. So if you are taking like this, then you have to resolve all the vectors along x or along y direction. Acceleration is already along x-axis direction, negative x-axis, and mg is along negative y direction, right? So I need to only resolve normal force and friction. So friction component along this direction will be what? Now friction, no, this is not your x direction or y direction. Friction component along this direction is Fr sine theta. How it is? This angle is 90 minus theta. So Fr cos 90 minus theta is Fr sine theta. And along this direction, friction will have a component of Fr cos theta. Okay. Now once I resolve the forces into its component, I don't need to draw that force because it is already equal to Fr sine theta along negative axis and Fr cos theta along negative x-axis. So friction is sum of these two. Now normal reaction along this direction, normal reaction will have a component of n cos theta. Okay, and along this direction, it will have a component of n sin theta. So I'll just put it in a clear form. It is n sin theta. Okay. So we have n cos theta, Fr sin theta, and mg along vertical direction, and n sin theta and Fr cos theta along this negative x-axis. Okay. Now this equation will give us n sin theta plus friction cos theta is mass time acceleration, which is mv square by r, right? And this equation will give me n cos theta minus Fr sin theta minus mg is equal to 0 because there is no acceleration along y direction, right? Now, what is the value of friction? If coefficient of friction is mu, let us say mu s is coefficient of static friction, the maximum value of friction can be mu s into n, right? So will maximum value of friction be applied right now when I am having maximum possible velocity? The car is about to skid, right? So the friction will apply maximum possible value, so which is mu s times n. So friction in this case will be equal to mu s times n, right? So when I substitute friction is mu s times n, I'll get n cos theta minus mu s times n sin theta equals to mg. This will give me normal force as mg divided by cos theta minus mu s sin theta. Why we have to find out normal reaction? Because in this equation, let us call this as equation number 1 and this as equation number 2. In equation number 1, I do not know the value of n. I want to find out velocity, right? So now friction is mu s times n. So my equation number 1 will become n times sine theta plus mu s cos theta is mv square by r. Okay. Now when I substitute value of n there, it will become this, right? So I can cancel out m. Okay. So velocity is equal to under root of gr sine theta plus mu s cos theta divided by cos theta minus mu s sin theta. So this is maximum possible velocity. Okay. Now look at this expression carefully and we'll draw some conclusion. So when the road was flat, okay, when the road was flat, V max was what? Under root of mu s gr. Okay. Now is this V max because of this angle theta more than mu s gr or less than mu s gr? In order to compare it, what you should do is divide numerator and denominator by cos theta. So it will become tan theta plus mu s divided by 1 minus mu s tan theta. Okay, raised to power half. So theta is very small angle, alright? So tan theta will be a positive number, okay, and a very small positive number. So numerator is more than mu s gr. Okay, let us look at denominator. Now mu s tan theta, value of that will be less than 1, but it will be between 0 and 1. It will be a positive number. So denominator is less than 1 and numerator is more than mu s gr, right? So of course this time maximum velocity is more than what it would have been when the road was flat. Okay, so that is the reason why the banking will help you to maintain higher velocity at the turn without skidding, right? Now another way you can check whether your expression is correct or not, you know, you should get mu s gr when you put theta equal to 0, because for a flat surface this angle theta is 0, right? So let us check that. When you put theta equal to 0, tan theta becomes 0 and this also becomes 0. So it becomes V max equals to mu s gr to the power half, which is equal to this. Okay. So this is what the derivation is for the banking of